Hey, what's up, Pre-Cal 12? This is Coach Jay on Friday. Hope you're having a great day as we head into the weekend. I know that I'm out today, but good for you. We've got a podcast that's over a lot of the homework problems that you may have some questions on. What my job is I want to hopefully get you a great starting point as you begin this process and as you head forward through it, okay? So again, my goal today is hopefully to help you with that, help you off of that 5.4 homework, and we'll do it. We'll kind of go off that, all right? So without further ado, let's go right straight into it. Couple things. First off is things that are due. If you get the homework 5.4 done before 3 o'clock and you submit it online before that 3 o'clock deadline, you'll have bonus on that homework for 5.4. We'll throw some challenge points in there for you. Just as a thank you for being diligent when I am gone. Also, again, you're watching the podcast, so you've got step one. So the podcast, 5.4 homework, and then afterwards you can either start on the review, which is online, or you can go into the second thing, which is the just kind of go work on something quietly in another class. But be sure, please, I'm asking you, watch this podcast and then do 5.4 homework prior to then doing the review or working on another class, all right? All right, let's get started. We'll get that rolling. Today we've got just kind of a review over 5.4. We've already kind of hopped into it already. One of the main things to kind of remember that I wanted to just touch base with you on is number one. Well, number one tells us to find the exact value of the sine, cosine, and tangent of the angle. So you're using sum and difference formulas, right? The problem is that I can't find that one on my unit circle. So I've got to do something that's different related to sum and difference, right? So one thing I do is anytime I'm having radians, I can take 13 pi over 12, okay? And we can multiply that by 180 over pi, okay? Put that down there. Okay, perfect. So once I take 180, and I'm just going to do this on my calculator, I know the pi's will cancel to where once I get that, I'll get 180 divided by 12. And then I can multiply that by 13 to where when I do that, I get 195. Now, this is important. Once I get 195 as my angle here in terms of degrees, I can take that now and say what two angles when added or subtracted get me to 195. Well, one thing that I can do is just kind of out on the side here. I know that let's say I was doing the sine of this. Let's say I could do, and you could piece it together however you want to, but I'm going to do 150 and 45 because again, both of these angles must be on my unit circle to actually use, right? The point of this is the fact that I don't have a unit circle, so I can't use it, it's not on my unit circle rather, so I can't use it. So I need two angles that add to equal 195. So that's 150 plus 45. Once I do this, now I get sine of A, and it's cosine. Or I'm sorry, sine A. I believe is it sine A, sine B? Let me do this. Let's look on that real quick. And this is why you need your identities on that. Let's see here. If you don't have them, this might be a good time to just use it. Yeah, sine A plus B was cosine B. That was my fault there. I'm going to backtrack here. So sine A cosine B, that was right there. And then plus, same sign here, sine B cosine A. Or I think on the formula it says cosine A sine B, but I mean, same thing. We just flip-flopped them. So A is 150. So we're going to do sine of 150 here, okay? And cosine of B, B is 45 degrees, okay? So we got that there. And plus, and the B is, again, sine of B, sine of 45. And the cosine of A is cosine of 150 here. Okay, so now as I check out my unit circle, I remember that sine of 150 is, as I look at that, as I remember that, I believe that should be positive 1/2. Cosine of 45 should be square root of 2 over 2. Okay, the sine of 45 is square root of 2 over 2. Okay, again, and cosine of 150 is negative square root of 3 over 2. Be sure to take the signs with it. That's important in all of these. So now when I distribute, I get square root of 2. Make sure you do the top and the bottom. So I have square root of 2 over 4 plus negative square root of 6 over 4. So I would say this. I would say square root of 2 minus square root of 6, because plus minus is the same as subtracted. And that'll be all over 4 there. And so I have square root of 2 minus square root of 6 all over 4. And that would be my answer. And so that would be the sine of that specific angle. Now, what I would do, because I've got to find sine, cosine, and tangent, I'll have you do the cosine part. What I'll do is the tangent part here. So same thing. This is going to be tangent A plus tangent B. Okay, so you just plug it in just like you did earlier. 1 minus tangent A, and then tangent B. Okay, so again, once I plug this in, A would be the 150, right? Okay, so we're going to plug 150 in. B would be the 45. Okay, A is 150, and B is the 45. Okay, so once I plug that in, what I do is I say, okay, what's tangent of 150? Tangent of 150. Now, this is where it gets a little bit tricky from what we were doing in class, just a little bit, because actually 150, if you think about it, when I do y over x on this side, 150, I should get negative square root of 3 over 3. Check me on that, but it should be negative square root of 3 over 3. You can use your shortcut, remembering that, remember this 30-degree angle when I do y over x was over here in quadrant 1, square root of 3 over 3. So you can remember that, but when it's 150, it'd be actually negative square root of 3 over 3. Okay, now once I get that, and I'll cross that off because I've got it, tangent of 45 should be 1. So we're just going to put 1 there. So we got 1 plus that. Over here on the bottom, same thing. This should be square root of 3 over 3. And 45 is this one. So I've got these two canceled. So I should have 1 minus square root of 3 over 3 times 1 there. So once I get this, here's what I've got. I've got negative square root of 3 over 3 plus 1 all over 1 minus square root of 3 over 3. So on this, I've got to get a common denominator on top and bottom. So over here, let's get 3 over 3 by multiplying top and bottom. Over here is 3 over 3. So I should get negative square root of 3 plus 3 all over 3. And then on the bottom, we should get 3 minus square root of 3 all over 3. So once I get that, what I have now is I could flip this bottom to the top, and hopefully you can see this on top of the sign. When I do that, I get 3 over 3 minus square root of 3, right? Because I flip it to the top. And the 3's cancel, leaving me with negative square root of 3 plus 3 all over 3 minus square root of 3. And right there, actually, this would be sufficient. That would be your answer for that tangent that's there. Now, the tough part is just getting that common denominator on top and bottom. But overall, not too bad with that. And you do the same thing with cosine. All right. So I did 2 for you there. Hopefully that helped you. One of the things to mention here is on number 3. And I'm just going to mention some things here. This right here would be like sine of u, cosine of v, right? Now we're using v and u. It's kind of a little weird, but same concept. If it was cosine, we'd plug the same formula. We'd plug a different formula in, but same thing. Okay, make sure you know what is v, what is u. So the u's, I want to make sure you know this. That's the u and that's the u, whereas the v is here and here. Now, since I was given, and you can't see it here, I think let me make sure I might have put that. Where did I put that? It's not there. I think it's on 5.4. Okay, I don't have it here, but on this example, let's see if we can pull up 5.4 actually. Let's see here. All right, so it actually didn't pull up here, but you see it. Let's pull it here. Let me copy this. My fault there, y'all. I had everything. There it is. You see it up in the top corner there. You see like cosine and sine, that's what was given. Remember, in this situation, we want to have 2 different triangles. Both are in the quadrant 2. So what we're going to do is for u, we'll make it here. This would be u. And the second one will be V. V will be here. And this one, this is V. So U is here, V is here. So U would be 5/13, which is opposite over hypotenuse, okay? So the opposite side would be 5. Hypotenuse side would be 13 here. So then I would use quadratic, or the not quadratic, Pythagorean theorem to solve for what the adjacent side is. Make sure that it's negative, okay? It's actually going to be, I think it's negative 12 here. Okay, so when you do Pythagorean theorem. For V, this is adjacent over hypotenuse, right? Because this is the V over here on this side. So the adjacent would be negative 3. Hypotenuse would be 5. This is a 3, 4, 5 triangle. The 4 will be positive because it's going up in the second quadrant. So why do I say that? Well, now I can know that not only do I know sine of U that I can plug in for this whole thing. I'll literally put in 5/13 in for here. But I can actually find cosine of U by doing the adjacent over hypotenuse. So cosine of U would be negative 12/13 that I would plug in for here, right? And I would do the same thing for the other side. So I have sine of U is 5/13. Okay, so like for instance, okay, I've got those two, right? Now we're going to multiply cosine V. Cosine is negative 3/5 because it was given to us. It's also my adjacent over my hypotenuse there. And my sine of V, what I had to solve for, that's why I have the triangle, right? Because I knew cosine already. Sine would be 4/5. So I'm going to, again, multiply across, add. I should have common denominators already, so multiply these two across, both top and bottom. And then since it has common denominators, I add and I'll have a whole value that's there, okay? Within this next one, I think this is in the review section. I'll say it here. Let's pretend that we're trying to find values between 0 and 2 pi. One thing to note is that I have two different things here, but one thing to remember is that I can actually divide by cosecant on both sides, right? The reason why I can do that is because once I have 2 times cosecant, I see that it's on the other side. If I were to divide both, I could actually take out both of them there, okay? So what it does now is I can then find secant of x equals the value of 2. So I say, my question is where is secant going to be equal to 2? Well, secant will be equal to 2 at 2 locations, right? You could also flip this to say where is cosine of x equal to 1/2. You could say as well, okay? You could say that. And I know cosine of 1/2 is going to be at 2 locations. It should be at pi/3. And it's positive at, I think it's 5 pi/3. You'll have a unit circle there, but check me on that. And then if it doesn't say from 0 to 2 pi, then you'll have to add 2 pi right there, 2 pi n, I'm sorry. And so you'll add 2 pi n there as well. Okay, if it does say from 0 to 2 pi, you would only need those answers there, but just want to make sure I hit on that moving forward, okay? Hey, I know that this has been very, very quick for you, and I appreciate your willingness and your help there. We're going to look at one more on this, and that's the section B. This same thing is what you would apply to something, let's say, like this, okay? In fact, I might even do that one just so that we've got it here. Let's see if I can. In fact, I'm going to do that one. I'm going to do that identity one. I'm going to change it up. We're going to do this one. Let's see if you can. Got it here. Let's see. Okay. Let's see if I can. All right. We're going to do this one on the board here. So I'm going to kind of go. Awesome. It goes on that left. Okay. Awesome. Okay. So let's go. Let's put this down. This is an identity that we're going to try to use to solve and that sort of thing. And what we're doing is just like verifying identities, we're going to use our formulas here to try to break this down. So we're kind of combining sections 5.1 and 5.2. All right, that's kind of the goal. In fact, I think this one even says, it says solve. So we're actually not even verifying. Some of them will say verify. This one we're actually solving, but we're using the same formulas that are there, okay? So the values that we're trying to find is between 0 and 2 pi. This is a really good one, okay? Okay, so first thing is I know I can't distribute the sign, right? We talked over that. We can't distribute the sign on this one. So we've got to figure out, let's see if we can pull this up. I'm sorry. There we go. We can't distribute this, okay? There's no way to distribute it. So we have to figure out, okay, what formula can we apply to be able to simplify this or get this out. So we go straight into our sum of difference formulas, right? We talked over that already. So on this would be sine of A, cosine B, right? Plus sine A, cosine B, all right? This one, because it's a minus, would be sine A, cosine B minus sine A, cosine, or sine B, cosine A, right? That's the idea. So what I'm going to do, I'm going to put this down. Sine of A, cosine B, plus cosine A, sine B, all right? Now, I'm going to just do this first one. Because A is x, we're just going to put that out. So sine of x, cosine of pi over 4, plus cosine of x, sine of pi over 4, okay? We're going to put that down. Perfect. Okay, let's look at the next one. This next one, we're going to do the same thing with, except now there's only a minus in the middle. So we're going to keep the same thing down, just a minus in the middle. So it should be the same plus sine of x cosine of pi over 4, right? And then we'll do minus cosine x sine of pi over 4. Am I running out of room there? Okay, no, we're good. So now that's everything. This is going to be equal to -1, okay? Now look at this really quick. Now this looks really complicated, and it is a little bit tough. But you see how we use the sum and difference formula to simplify it out. Now look a couple things here. You'll notice that cosine x sine of pi over 4, there's two of these, but one is positive, one is negative. That kind of helps us out to determine that we can cross those out, with one being positive, one being negative, and they're both the same thing. So these are going to be canceled, okay? So now we're going to go to our next part, and you'll notice that we have right now 2 sine x cosine of pi over 4s, right? Kind of two of them here. So what we can do is we can actually combine those. So we'll just say that we have 2 sine x cosine of pi over 4, because 1 plus 1, we know we got kind of combine them to just keep it the same, and now we've got 2 that equals -1, okay? All right, now we're almost there, we're getting there. Now cosine of pi over 4, if you went to the unit circle and solved for that, cosine of pi over 4 would be square root of 2 over 2, right? Okay, so this whole thing here is actually square root of 2 over 2. And then since all of this is being multiplied, if I multiply 2 times square root of 2 over 2, the 2's would cancel, leaving me with square root of 2 times sine x equals -1. So now I can keep going, right, and divide by square root of 2. All I'm doing is simplifying. Now, because of that now, square roots in the bottom, we don't like that. So we're going to multiply top and bottom by square root of 2 over 2, square root of 2. And this right on the right side will be negative square root of 2 over 2, okay? And that equals sine of x, all right? So here's the thing. What's cool about this is you can kind of get in all the, oh my goodness. The big thing is just take it step by step down and isolate that sine of x there. It should work out. We're not going to give you one that's going to be like extremely complicated. It's going to work out. It may look complicated, but it will work out there. So once I get here, what is sine of x? Where is sine of x? Negative square root of 2 over 2. There's 2 locations in quadrants 3 and 4. If you look at your unit circle, there should be 2 locations. That answer should be at 5 pi over 4 and 7 pi over 4. And again, we only need those 2. We don't need the 2 pi in, because we knew that it should be between 0 and 2 pi. Hey, I hope that was helpful for you today. I know that it was a little lengthy podcast, but hopefully in doing some of those homework ones, that will help you get a leg up on that. Remember 5.3, make sure we have that. We should have already had that turned in there. And then 5.4 is going to be due on Monday at midnight. But if you can get it in before 3 o'clock today, get those challenge points, get those extra points in, especially if you had missed a homework even earlier in the year, that might help you. Okay. All right. Thank you so much. Appreciate your attentiveness. Have a fantastic Friday. We'll see you all Monday. Bye.